In this section, we're going to discuss radical equations and an application of radical equations. So far, we've done a good job of, working with radicals, simplifying, adding, subtracting, multiplying, dividing them. And now we're at a point where we can actually solve some radical equations. All right, down here we have an example of a radical equation. Notice it's just basically an equation with a radical in it. But to solve these, we have to follow some steps so that we can get rid of that radical. So the huge issue is when our variable is under a radical. We need to find out some way to get it from being in under that radical. And basically we're going to use those properties that, hey, for instance, if I take the square root of something and square it, the square root and the square kind of cancel. All right, we're not going to be thinking about this absolute value stuff right now as we see it. But the same thing happens when we take the cube root of something, right? If I take the cube root of something and cube it, then I'm just going to be left with whatever's under that radical. Same thing happens if I take the fourth root of something. All right, I'm going to raise it to the fourth power, and the fourth root and the exponent 4 are going to cancel just like these. So all of these are going to equal just whatever's under that radical. We're going to use this knowledge to help us solve these equations. Now, what we have to do, all right, I have some steps here. What we have to do first, before we start to raise stuff to our power, our index, is we're going to have to isolate the radical. That means get the radical on one side completely by itself. After that happens, we're going to raise both sides to the nth power, and here n is the degree, right? N is the degree. So if it's a square root, raise it to the second power. If it's a cube root, raise it to the third power, so on and so forth. All right. Next, we're going to check and see, right? If the resulting equation doesn't contain any radicals, then we're just going to have an equation with just x, and we can solve it like normal. It might be a linear equation. It might be a quadratic equation, but we'll be able to solve once we don't see any radicals anymore. However, if it does contain a radical, we're going to repeat the process once again. We're going to isolate the radical, raise both sides to the nth power, and hopefully we will no longer have a radical. So this step is it's very important. We'd like to just have no radicals in the first step and then solve for x, but sometimes that doesn't happen. And at the end, what we're going to do is we're going to check our solutions. And the reason why we have to check our solutions is because we're kind of doing something, we're not doing something illegal, but as you know, when we take the square root of something squared, this thing can be positive or negative, or it's supposed to kind of equal the absolute value of x. And so sometimes we're going to get solutions that are extraneous, that won't actually work in our problem. And we'll see some examples here. All right, let's look at this first example here. The cube root of 2x minus 7. We're adding 5 on the outside of that, and then we're going to set that equal to 8. All right, first up is to isolate the radical. Well, my radical is here. The only thing that's preventing it from being isolated is this plus 5 that's on the outside. So I'm going to subtract 5 from both sides. And when I subtract 5 from both sides, I'm going to be left with the cube root of 2x minus 7. Equals 3. Okay, now that radical is isolated, it's on one side by itself, so I'm going to raise both sides to the index power. My index here is 3, so I'm going to raise both sides to the third power. You got to do it on both sides, and it's only after it's isolated. The third power and that cube root, they cancel, and I'm left with just 2x minus 7, and 3 cubed is 27, right? To solve this for x, I will add 7 to both sides. When I add 7 to both sides, I'm going to get 34. Then I can divide both sides by 2, and I'll get that x equals 17. All right, so this is my possible solution. Now I'm going to check that solution. Okay, and basically I'm going to check x equals 17. I'm going to substitute 17 into my original equation. So I get 2 times 17 minus 7 plus 5 on the outside, and I want to make sure that that equals 8. If it does, then it is my solution. Well, that's going to be the cube root of 34 minus 7. We're going to add 5 to that. See if that equals 8. Well, 34 minus 7 is 27. And just to save some, well, let's just go ahead. That's 3 plus 5 equals 8, which is true. So my solution here is 17. Okay. Had this been false, then I would have no solution. Let's look at another example. In this example, we have x equals the square root of 49 minus 8x plus 7. And we want to solve for x. All right. Again, I'm going to take the same steps as I would before. I'm going to isolate my radical. All right. So my radical is here. The thing that's having me or preventing me from having it isolated is that plus 7. So I'm going to subtract 7 from both sides. When I subtract 7, I'm going to get x minus 7 equals the square root of 49 minus 8x. Okay, so my radical is now isolated. Now I'm going to raise both sides to the index. Of course, there's a 2 understood to be there since we're taking the square root. So I've got to square both sides. When I square both sides, on my left-hand side, I'm opening myself up for a FOIL method. All right, so remember that. Don't try to square the x and square the 7. You actually have to FOIL it out. And that disappeared. My radical disappeared. But here, when I have the square root and I'm squaring it, I'm going to be left with whatever's under that radical. 49 minus 8x. I'm going to FOIL this out, but I'm going to do it pretty quickly. This is a perfect square. This is a perfect square trinomial, so it's going to be x squared minus 7x minus another 7x, so that gives me minus 14x plus 49. And that's going to equal 49 minus 8x. Of course, since my highest power is x squared, what I'm going to do is I'm going to get everything on one side. This is a quadratic equation. To solve that, we have to factor. So I'm going to subtract 49 from both sides. And if I want this side to be 0, I need to add 8x also. Okay, remember with a quadratic equation, we expect to have 2 solutions. Negative 14x plus 8x is a negative 6x. And those 49's cancel. And everything on the right-hand side cancels to 0. So I get x squared minus 6x equals 0. Of course, we can factor. First step in factor is to factor out your GCF. My GCF here is 6. X. After I factor out x, I'm going to be left